Okay, hello, this is Dr. Hanaa Assil, and today this is Unit 1, January 2022, in the IAS Chemistry Edexcel. And let's take a look at the questions and discuss the answers. So the first question is element X is in group 2 of the periodic table, and element Y is in group 7. What is the formula of the compound formed from X and Y? So he's looking at something in group 2 with something in group 7. Remember that that means that they are ionic compounds, and anything in group 2 will have a valency of 2. So I should have 2 under the Y. And Y is in group 7, so it has a valency of 1. So if I'm going to write the formula, it will be XY2. Remember, the valency of 1 goes under the other. Anything in group 2 has a valency of 2. Anything in group 7 has a valency of 1. Under what conditions does the compound formed from X and Y conduct electricity? We said anything from group 2 with group 7, that means it's ionic. Ionic will conduct electricity in what? It will conduct electricity in the liquid state and in the aqueous solution only. Which of these compounds would you expect to have the highest melting temperature? Okay, if we look at all the choices, they're all ionic. Now, which of these will be highest? Well, we're looking at what? We're looking at sodium with chlorine, sodium with fluorine. So if I'm looking at sodium with chlorine or with fluorine, which one would have higher melting temperature? You should realize that it will be sodium with fluorine. Fluorine is the most electronegative element, so the ionic bond between sodium and fluorine will be strongest, and it will have it will need more temperature or higher temperature to be broken. So sodium with fluorine is a very strong ionic bond. If we're comparing the sodium with group 7 or the potassium with group 7, remember that potassium is a bigger atom, so the attraction forces between them will be less for potassium than with sodium. So actually the one with the highest melting temperature is sodium fluoride. A drop of an aqueous solution of green copper chromate is placed in the center of a strip of damp filter paper. The ends of the filter paper are connected to a power supply. What is observed after a few minutes? Remember that he's saying that copper chromate is green. Of course, copper chromate is ionic. So if we put it on a paper that is connected to a power supply that has a positive end and a negative end, it breaks up into its ions. So what are the ions? The ions are chromate ions, and chromate ions are the yellow ones, and they are negative, so they will go towards the positive. The copper ions, you have to know, even if you're not familiar with the color of the chromate ion, you should know that the color of the copper ion is blue. And the copper ions are positive, so they will go to the negative. So which statements are correct? It is statement C that says a yellow color has moved to the positive and a blue color to the negative. Which of these isoelectronic ions has the smallest ionic radius? Remember that we said if all the ions are isoelectronic, that means they have the same number of electrons. Which one would have the smallest radius? We said if we're looking at it, the one with more protons in the nucleus is the one that will have smallest ionic radius because it is attracting the same number of electrons. So look at nitrogen, it has 7 protons attracting the total number of electrons. Here is what? We have a total number of electrons of 10 for all of them. So nitrogen has 7 protons attracting the 10 electrons. Fluorine has 9 protons attracting the 10 electrons. Sodium has 11 protons attracting the 10 electrons. Aluminium has 13, so aluminium must be the smallest. Okay, which properties of a cation result in the greatest polarizing power? Remember, we said polarizing power is the ability of the cation to attract the negative ion to itself so that it polarizes or it distorts the electron cloud around the anion. So we said for a cation to distort this electron cloud and cause polarization, we said the cation should be small with more charge, with larger charge. So the one that has a small radius with larger charge, that would be the cation that causes greater polarizing power. Now, the next question says, which properties of an anion result in it being most easily polarized? Then we said the anion, to be able to be easily polarized, it has to be large and large charge. So a large anion with a large charge will be more likely to be polarized. What is the ionic equation for the reaction between aqueous solutions of barium nitrate and sodium sulfate? Well, you should know how to do this. So let's say how to do it first and then how we can recognize it without doing it. So if I have an aqueous solution of barium nitrate and sodium sulfate, this is the equation that, and you should pay attention to the state symbol. So the barium nitrate, any nitrate is aqueous, sodium sulfate, sodium anything is aqueous. Barium sulfate, you should know, is a solid, it's a precipitate, and sodium nitrate is aqueous. Do not forget to balance. So here we're going to balance this equation. So this is the equation that we have. And then to change it into ionic, we said we ionize all the ones that are aqueous. We do not ionize solids or liquids or gases. Okay, then after ionizing, we find that we have this barium ions, nitrate ions, sodium ions, sulfate ions. The barium sulfate remains as it is, it's a solid. And then the sodium and the nitrate ions are ionized. And then we cancel whatever is the same on both sides of the arrow. So the sodium ions cancel, the nitrate ions cancel, and I'm left with barium ions, which are aqueous, plus sulfate ions, which are aqueous, to give barium sulfate. I'm going to tell you that without doing all of this, you should realize that barium nitrate and sodium sulfate react to form a precipitate of barium sulfate, because this was test for sulfate. And if I want to write the ionic equation for formation of barium sulfate, of course it would be made from barium ions and sulfate ions. Okay, which of these molecules is not polar? Remember, polar bonds are the ones in which one of the atoms is more electronegative than the other. A polar molecule is where the polarities do not cancel. So he's looking for which one is not polar. That means we're looking for which one the polarities cancel. So if we draw carbon dioxide, you should realize that carbon dioxide is a linear molecule. The polarities, oxygen is more electronegative than the carbon, so the polarities cancel each other. So actually this is the molecule that is not polar. If we draw HCl, there is a polarity. The chlorine is more electronegative than the hydrogen. Water, there is polarity because the molecule is not linear. The molecule, you should realize, is V-shaped or non-linear, so the polarities do not cancel. Ammonia is a pyramidal shape, so the polarities also do not cancel. So the one that is not polar is carbon dioxide. Concentration of nitrogen dioxide in a sample of air is 0.5 parts per million. What is the percentage of nitrogen dioxide molecules in this sample of air? So here he's given me the parts per million, and he wants me to determine what is the percentage. Remember, this is how we get. This is the equation that we use to get parts per million. The massing grams over the total massing grams times 10 to the power 6, that is what we call parts per million. So he's given me the parts per million, it's 0.5. And he wants to get the percentage. Percentage means how much in 100. So my total mass, if it's 100, I'm trying to get X. So to solve for X, the concentration comes out to be this. So that is number C. Ethane reacts with bromine in the presence of UV radiation. What is the equation for the reaction? Again, remember, alkanes react with halogens. In presence of UV light, this is called substitution reaction, in which I remove one of the hydrogens from the ethane and replace it by one bromine, and the other product would be hydrogen bromide. So the reaction that happens is substitution reaction in presence of UV light. So which one is correct? That is the one written in B. The UV radiation is needed for what? Do you remember how to write the mechanism for this? You should remember that the UV light is needed for the initiation step, in which you have homolytic breaking of the Br-Br bond. So what happens in this reaction is the UV light breaks the bonds homolytically. Homolytically means one electron from the bond goes to each bromine atom, and I end up with two bromine radicals. So it forms a free radical, and then this free radical goes on to do propagation steps and termination steps. So that would be the answer in A. All alkanes have the same what? Well, let's see. Remember alkanes? Alkanes like methane, ethane, propane, butane, pentane, they have um, a sequence of number of carbons and number of hydrogens. So we say the general formula is CnH2n plus 2. So all members of the same homologous series like alkanes would have the same general formula. They would also have the same functional group. So alkanes, for example, all have single bond C. So my answer here is the same general form, not molecular, not structural, not empirical. A single molecule of decane is cracked. Which of these mixtures could not be formed? Remember, cracking means I'm starting with the decane C10H22 and I'm breaking it up into two or more molecules. So he's saying which of these could not be formed. You should know that the total number of carbons and hydrogens in the products should be the same as the number of carbons and hydrogens in the decane. So if we're saying we're breaking decane to form pentene and pentane, is that possible? Yes. The total number of carbons is 10 and the total number of hydrogens is 22. So this one is possible. He's looking for which one is not possible. Okay, if I break the C10H22 to form ethene, butene, and butane, is that correct? Yes, that could happen because the total number on both sides of the arrow is the same. What about in C? Propene, and propane and butene. Again, if you add them all up, they will give the correct number of carbons and hydrogens. But if we break up C10H22, can I end up with hexene and propane? Well, hexene is C6H12, propane is C3H8. So the total number of carbons is not 10. And the total number of hydrogens is not 22. So I cannot get this. So this is the one that could not be formed. How many structural isomers have the formula C3H6Cl2? So you want 3 carbons and you want to put the 2 chlorines in all the different arrangements that you can have. So this would be the type of arrangement that you will have. So you have only 4 different types of structural isomers. Can you think of anything else? You will not, because and anything you'll come up with will be the same as one of these. So actually you can have only 4 different arrangements of the 2 chlorines on the 3 carbons. The equation for complete combustion of hexane is shown. How many molecules of carbon dioxide are formed when 2 times 10 to the minus 3 mole of hexane undergoes complete combustion? So you have number of moles of hexane, and he's telling you how many molecules of carbon dioxide. Well, I have to relate the number of moles first. So the number of moles of carbon dioxide from the equation is 6 times the number of moles of hexane. And then how do we get number of molecules? Number of molecules, you multiply this number by Avogadro's number, which is 6.02 times 10 to 23, and that ends up with the answer in B. Which pollutants cannot form when alkane fuels are burned? Okay, when we burn alkane fuels, what kind of products can we have? We can have carbon monoxide if it is incomplete. We can have carbon alone. Can we have hydrogen chloride? We cannot have hydrogen chloride. We can have sulfur dioxide because most fuels have sulfur impurities. But the ones that I cannot form is hydrogen chloride. Iron 3 oxide is reduced by hydrogen in a two-step process. What is the maximum mass of iron that could be produced from 39.9 tons of Fe2O3? Okay, I'm going to remind you first of all that the equations for the number of moles should be done in grams. And the ton is 10 to the power 6 grams. So actually, I should convert this ton to grams and then convert it back to tons. So anyway, he says he wants the mass of iron. If I start with 39.9 tons of Fe2O3, so let's get the number of moles of Fe2O3 first. The molecular mass is 159.6. So the number of moles is mass over molecular mass, and this gives me a number of moles of Fe2O3. And then I look at the equation and I relate the number of moles. You will find that from the first equation, the number of moles of Fe3O4 should be related to the Fe2O3 in the number of moles of the Fe2O3. If it is 3, it gives 2. So if it is 2.5 times 10 to the 5, it will give how much? So that means you multiply by 2 over 3. That gives me the number of moles of Fe3O4. And then from the second step, what is the number of moles of iron related to that? Number of moles of iron is 3 times of that. So this gets the number of moles of iron. Now he wants mass. Well, mass is number of moles times mR. So my answer comes out to be 2.79 times 10 to the 7, but I need to divide that by 10 to the 6 in order to get it in tons. Are we following? Okay, which of these solutions contains the greatest number of ions? So the previous question, there was a question where he says the number of molecules. The number of molecules, you just multiply the number of moles by Avogadro. But the number of ions, you have to multiply the number of moles by Avogadro by the number of ions. So for KCl, the number of moles is concentration times volume. And then I should multiply this by Avogadro's number by the number of ions. What is the number of ions? It's 2. In the next question, it comes out to be 0.024. In C, I have calcium chloride, so the number of moles is concentration times volume, and you're supposed to multiply this by Avogadro's number by how many ions? By 3. So, and in D also, it's calcium chloride, I multiply by 3. So which of these gives the greatest number of ions? It will be the one in B. Of course, the number of ions would be this number multiplied by Avogadro's number. Potassium chlorate decomposes on heating to form oxygen. What is the atom economy by mass for formation of oxygen? How do we calculate atom economy? Remember that atom economy is the mass of whatever I am talking about. So here we're talking about oxygen over the total mass of products. So here I have 3 oxygen, so it is 3 times 16 times 2. That is the MR of the product I'm looking for. Now, over the total mass, so that is 2 times the MR of KCl plus 3 times the MR of O2. So this percent economy is 39.2. This question is about the amount of water of crystallization in hydrated magnesium sulfate. The value of X was determined in an experiment, so he's trying to get the X. A crucible was weighed, spatula measure of hydrated magnesium sulfate was added, the crucible was reweighed. And then the crucible containing the hydrated magnesium sulfate was heated. After heating, the crucible containing the magnesium sulfate was allowed to cool and reweighed. Then this table gives the results, and he's asking what is the mass of magnesium sulfate after heating. Well, he has the mass of empty crucible, and he has the mass of the crucible and magnesium sulfate after heating for 2 minutes. So the difference between that, 24.12 minus 21.21, that is the mass of the magnesium sulfate. Now, what is the mass of water? Well, the mass of water would be the mass of crucible and hydrated before heating minus the mass of crucible and magnesium sulfate after heating. So it's 26.71 minus 24.12, that is the mass of the water lost. Use these results to calculate the value of X in magnesium sulfate, X water. Again, we said in order to get the value of X, we should do it as if we're doing empirical formula. The MR of magnesium sulfate is this. Now, we say we have magnesium sulfate, we said 2.91. The water is 2.59. We divide first by the MR of each one. The numbers that come out, I divide by the smallest. This comes out to be 1 to 6. So that means that my X is 6. The correct value of X is greater than the value calculated in A2. So just a way of improving this method to obtain a more accurate result. Remember that he heated only for 2 minutes. How does he know that all the water has evaporated? He really doesn't know. Because usually what we do is we should reheat and reweigh until the mass is constant in order to make sure that all the water has been lost. This question is about copper. So he's saying complete the electronic configurations of copper and copper 2+. And remember, he has argon in there. Copper is 29, the argon is 18. So I put the rest of the electrons. That will be for S1 3D10. Remember, we don't say for S2 3D9. A sublevel is full or half filled, then it will be more stable. So instead of saying for S2 3D9, I can say for S1. Actually, I should say for S1 3D10. In that case, the 4S is half filled, that is stable, and the 3D is completely filled, so that is stable. What if I have copper 2+? Copper 2+ means I will be losing 2 electrons. So my the electron in the 4S is lost, and I'm left with 3D9. Complete the table to show the numbers of subatomic particles in the atoms of the two isotopes. So if I have, remember that for all of these, the atomic number is 29. It never changes. So for copper 63, the protons are 29. Neutrons is the difference between the mass, the bigger number and the smaller number, and the electrons is the same as the number of protons. Explain the term isotopes. Well, isotopes are atoms of the same element having the same number of protons but different number of neutrons. And then he says using the information in the table. So you have to mention the information in the table. Both isotopes of copper have 29 protons, but they have different number of neutrons, 34 and 36. State why the two isotopes of copper have the same chemical reactions, because they have the same number of electrons. so they have the same electron configuration. The relative atomic mass of copper is 63.4. Calculate the percent abundance of the isotope. So here he's given me the overall atomic mass and he wants the abundance of each one. Well, you should realize that to get the atomic mass of the overall, what he did was he multiplied the mass of one times its abundance plus the mass of the other times its abundance. Now we can write an equation like this in which we say the abundance of copper 63 is x, the abundance of copper 65 is 1 minus x, and then at the end I should multiply by 100 to get percentage. Or you could write it x and the 100 minus x, but in that case the numbers are much bigger. So solve for x here, x comes out to be 0.8. That means that the copper 63 is 80% and the copper 65 is 20%. Copper sulfate can be made by reacting solid copper carbonate with dilute sulfuric acid. Write an equation for the reaction that occurs. So we're just writing a normal equation. He doesn't even want state symbols. So copper carbonate plus sulfuric acid to give copper sulfate plus carbon dioxide plus water. An experiment was carried out to produce pure dry crystals of hydrated copper sulfate. Copper carbonate was mixed with sulfuric acid. The mass obtained was 10.87 grams. Calculate the percent yield. In order to calculate the percent yield, I need to first calculate how much mass I should have obtained. So we have this equation. He says I have 50 centimeter cubed of 1 mole per decimeter cubed sulfuric acid, so I can get the number of moles of sulfuric acid. Remember, number of moles is concentration times volume. The volume has to be divided by 1,000 in order to change it to decimeter cubed. I get the number of moles of sulfuric acid. Then I look at the equation and I relate the number of moles to the number of moles of copper sulfate. I find that after balancing, the equation is already balanced. The equation has 1 mole of sulfuric acid gives 1 mole of copper sulfate. That means the number of moles of copper sulfate is the same as sulfuric acid. Then I can get the mass. The mass is the number of moles times the MR. And he already gives me the molar mass of the hydrated copper sulfate. So that means that I'm supposed to get 12.48 grams. Now, how much did he actually get? He got 10.87, so my percent yield is what he got over what he should have gotten times 100. So that comes out to be 87.1% yield. This question is about alkenes, and he says alkenes contain carbon-to-carbon double bond that consists of a sigma bond and a pi bond. Complete the diagram to show the areas of electron density of each bond and label which one is the sigma bond and which one is the pi bond. Remember, we said when we have a double bond, one of them is a sigma bond. That's the one in the middle. And then you have a pi bond that is made from overlap of p orbitals. So you have a lobe on top and a lobe below that makes up the pi bond. Propane is an alkene. The reagents needed for these reactions are shown. In each box, draw the structure of the organic product of the reaction. The first one is reaction of the propene with steam. If we react propene with steam, what happens? You should know that the double bond opens up and I put an H and an OH to form an alcohol. Now, what is the major product that you should get? It is the one in which the 2-propanol is obtained, in which the OH is on the secondary carbon. Now, acidified potassium manganate, remember acidified potassium manganate with an alkene will open the double bond and make what we call a diol, an OH on both sides of the bond that was a double bond. Bromine, we open the double bond and we put a Br and a Br. Propene also reacts with hydrogen bromide. Now give the mechanism to form the major product, include curly arrows and lone pairs and diamonds. So this is the kind of mechanism that you should have. The HBr has a slightly positive charge on the H, and the Br has a slightly negative charge. So the electrons from the double bond attack the slightly positive H, and the electrons in the bond between the H and the Br will go to the slightly negative Br. That leaves a secondary carbocation. So remember that the hydrogen is added to the carbon that had more hydrogens, so that the carbocation is the secondary carbocation that is formed. The Br minus attacks this secondary carbocation to form the secondary bromopropane, and that is the major product. Alpha-ocimene contains 3 carbon-to-carbon double bonds. It is found in plants and has a sweet smell. The skeletal formula of alpha-ocimene is shown. Give the molecular formula of alpha-ocimene. Okay, you should know what the skeletal formula represents. So if I want the molecular formula, I need to count how many carbons and how many hydrogens. You should realize that that skeletal formula that was drawn is actually this. So counting the number of carbons and the number of hydrogens, it is C10H60. Then he says, on the skeletal formula, draw a circle around the part of the molecule that gives rise to geometric isomerism. So which of these can have a cis and a trans? Remember that the double bonds on the ends cannot have a cis or trans. It is the one in the middle only that can have a cis or trans, because the others have similar groups on the carbons of the double bond. Then draw the skeletal formula of the other isomer. So remember that this has to be drawn so that it looks something like this. Okay, in an experiment, 0.05 mole of alpha-ocimene reacted with 3.6 decimeter cubed of hydrogen in the presence of a catalyst. Deduce the structure of the product. So, okay, what are we doing? We're saying the number of moles of hydrogen that were needed is volume over 24, so that is 0.15 mole. And that means that if I see the ratio between the C10H16 and the hydrogen, it's a 1:3 ratio. So that means actually 1 mole of the ocimene reacted with 3 moles of the hydrogen. And that means that if I have this product, it reacted with 3 hydrogens. That means the 3 double bonds were removed to form the alkane. This question is about the bonding in elements of period 3. Sodium, magnesium, and aluminum are metals. State what is meant by metallic bond. Remember, what is a metallic bond? You remember that the metal is made up of layers of positive ions surrounded by delocalized electrons. So the metallic bond is actually the strong attraction forces between positive ions and the delocalized negative electrons. Melting temperature depends on the strength of the metallic bonding. Explain why metallic bond in magnesium is much stronger than that in sodium. Well, let us see what is the difference between magnesium and sodium. Magnesium is in group 2. It has 2 electrons in the outer shell. Sodium is in group 1, so each atom is surrounded by the 1 electron in the outer shell. So the magnesium ions are smaller with more charge, 2 positives. So there is stronger attraction forces between the magnesium ions and its delocalized electrons. As compared to sodium, sodium is a bigger ion, less charge, and it is surrounded, each atom just has 1 electron, delocalized electron around. In the elements silicon, phosphorus, sulfur, and chlorine, the atoms are joined by covalent bonds. Describe the attraction between the atoms in a covalent bond. What is a covalent bond? A covalent bond is the strong attraction forces between the shared pair of electrons and the positive nuclei of the atoms. Please don't say it's a bond between two nonmetals or something like that. The covalent bond is strong attraction forces between the shared pair of electrons and the positive nuclei of the two atoms. Explain why the melting temperature of silicon is much higher than that of phosphorus. Well, remember, both of them are nonmetals, so the difference would be due to its structure. Phosphorus is a small molecule. It's a simple molecular structure, so it has only weak London dispersion forces between the molecules. These need a small amount of energy to be broken, while the silicon is a giant covalent structure with strong covalent bonds between its atoms, and that needs a lot of energy to be broken. Remember that the phosphorus molecule is P4, but we're not talking about the covalent bonds in the middle. We're talking about the interaction between this molecule and another molecule, so this will be only weak London dispersion forces. Complete the dot and cross for a molecule of sulfur dichloride, and he's specifying that the dots are for chlorine and the crosses for sulfur. So please follow his notation. Remember that sulfur is in group 6, it needs 2 electrons. Chlorine is in group 7, it needs only 1. So the chlorine will share 1 with the sulfur, but the sulfur shares 2 electrons with 2 chlorines. And remember that each chlorine still has the rest of its 7 around it, and the sulfur has the rest of its 6 around. So just a value for the chlorine sulfur chlorine bond. Remember that the atom in the middle has 2 lone pair of electrons. So, and this repels the bonding pair of electrons with the chlorine. So we have bond angle is 104.5. This is, of course, for minimum repulsion between the electrons. We have 2 bonding pairs of electrons and 2 lone pairs. And the lone pairs, remember, repel more than the bonding pairs. So this closes up the angle between the bonding pairs of electrons. This question is about ionization energy, and he's saying the first ionization energies of period 2 are shown. Give an equation to represent the first ionization energy of lithium. Again, I want to remind you that ionization energy is the amount of energy needed to remove 1 electron from the outermost shell in the gaseous state. So remember that the state symbols have to be gaseous state, and you're removing 1 electron, so that means that you're ending up with lithium with 1 positive, since this is the first ionization energy. Explain why there is a general increase in the first ionization energy across the period. Well, let's see. When we look at this, we are seeing that there is a general increase in the first ionization energy going from lithium to neon. And the main reason for that is going from lithium to neon, the atomic radius is decreasing. Now, do you remember why it was decreasing? Because we said the number of protons increases as we go from left to right, and they are attracting the same number of shells. We're still in the same period. Therefore, there will be stronger attraction force between the outermost electron and the positive nucleus of the atom, so more energy will be needed to remove the electron as we go from left to right. Explain why the first ionization energy of oxygen is lower than that of nitrogen. Well, let's see. Nitrogen has 7 electrons, 1s2, 2s2, 2p3. Oxygen has 8 electrons, 1s2, 2s2, 2p4. And that means if I distribute them, you will find that nitrogen has a half-filled p sublevel. Oxygen has paired electron in the p sublevel, and the half-filled is more stable. The paired electrons in the 2p orbital of oxygen repel each other, so less energy is needed to remove the electron. All the successive ionization energies of nitrogen are shown. Explain the trend in the successive ionization energies of nitrogen. So let us see. Remember, as we go along, first, second, third, fourth, fifth, sixth, seventh ionization energy, the ionization energies increase. Now, as they increase, why are they increasing? Less electrons are being attracted to the same number of protons. So there will be stronger attraction forces, and that is why the second and third ionization energies are higher than the first. Then when we go to the fourth, there is an increase from the third ionization energy to the fourth because we're going from the 2p to the 2s. We're now taking an electron from the filled 2s, which is closer to the nucleus, and therefore we need more energy. And then there will be a big jump in the ionization energy between the fifth and the sixth. This is because when we have removed the first 5 electrons, that means we have removed all the electrons in that outermost energy level. I am entering into the first energy level, which is inside, closer to the nucleus, more strongly held with stronger attraction forces. So there is a huge jump in the ionization energy from the fifth to the sixth. A 0.210 gram sample of volatile organic liquid is injected into a gas syringe and heated in an oven at this pressure and this temperature. The syringe contains this volume of gas. Calculate the molar mass of C. Remember that PV is equal to nRT, but then that means that the molecular mass is the mass times R times T over PV, because the N is actually mass over molecular mass. So putting in the numbers, the mass is what he gives me, 0.210 grams. R is a constant, 8.31. The temperature has to be in Kelvin. He already gives it to me in Kelvin. Remember, if he gives it in degrees Celsius, you have to add 273 to change it to Kelvin. Then the pressure, he gives it in kilopascal. The pressure that should be put in here should be in Pascal. So I multiply it by 1,000. Times, he gives the volume in centimeter cubed. I want it in meter cubed. So I multiply by 10 to the minus 6. Now, doing this with a calculator properly without making a mistake, you get the MR is 86.2. Then he says the organic liquid C is a hydrocarbon. Give a possible name or formula for C. We said it's a hydrocarbon, that means it has carbon and hydrogen. I want the total MR to be 86. So what could possibly be? The answers here could be more than one possible answer. You just want it to be something that has carbon and hydrogen, and the MR is 86. So one possible answer would be hexane, because hexane is C6H14. If you calculate the MR of C6H14, it is 86. And that's the end of the paper. Thank you for listening. I hope it was useful to you, and we'll meet in the next video. Thank you.